Hey guys, welcome back to the Meck TV restoration project. I'm hoping this will be the final installment. I have a few more resistors and paper caps to replace, or I should say, I want to reinstall the rebuilt paper caps and take out the caps that I just temporarily tacked into place. I was able to find 4 of the 650 ohm resistors. I've installed them here. I need to dig up 2 more. But we're definitely in the home stretch, assuming no major problems crop up. Phew, it is finally done, with the exception of a single 150 ohm resistor. Good night, found one last carbon count for that. It's not horribly off, it measures about 190. So we'll let that go for now. Also, it seems like this set's been a little star for voltage. When I've done some checks while I was periodically powering this set up while changing this stuff out, the voltage seemed low, so I did 2 things. One, I took out that 18 ohm resistor that had drifted high. It was about 38 ohms. Put an 18 ohm in there. And I finally disconnected the diode from the selenium rectifier. I had them in parallel all this time. Alright, so I want to power this up, make sure it still works. I checked the B+. I got the SAM service info that has a voltage chart in it. And if we look on the schematic, on power supply, they show a couple things we can check. Pin 8 on the 25Z6 and pin 3 on the 25Z6. So pin 3 is right after the rectifier and that 18 ohm resistor. Let's see, pin 3, they say should be 130 volts DC. And let's see, pin 8. Well, it's actually going to have AC on it, so forget that. Yeah, of course, that's right on the AC line, so I'm not going to mess with that. Alright, so without further ado, let's get this powered up. And we can easily check that. It's just the side of the resistor. Let's see what we get. Well, I said it should be 130. That's higher than that because right now there's no load. You see the current draw is going up as the tubes warm up. Oops. Slipped with the probe. Alright, that's better. Before it was more like 120. Alright, cool. Let's see, I do have it hooked up to a signal source, and do we still have an image? Yes, we do. Shrunken, distorted. Hey, we have sound. Cool. Now the fun stuff. So, I want to go through and adjust everything. For starters, excuse me, the trimmer cap, it's like this black box, I need to adjust. So we have 5,000 volts right at that black wire. That's the output of the high voltage generator. Don't worry, I'm not going to shock myself. And then I want to adjust the horizontal linearity. I want to do those 2 adjustments while I've got this set up on the stand because I need to access the bottom of the set to do it. The other stuff I can do with the set down. It's all adjustments made with these controls on the back. Alright, so first up, high voltage probe. That's just one more thing I really like about these Fluke 27 FMs. They come with a 6,000 volt probe, which is absolutely perfect for working on sets like this. Alrighty, so what do we have? Ooh, 3.8. Well, that'll explain why the image is on the dim side. So, got an adjustment tool here. It's a plastic tube with a metal slotted device on the end. Goes in the hole in the back, and there's a trimmer cap in there. Feel around for it. There it is. Let's see, if we go clockwise, it goes down. Clockwise is increasing the capacitance. Let's go the other way. almost perfect, 5,000 volts. And yes, the face of the CRT is brighter now. Also drawing more of an arc when I bring the probe to the contact point. It's going to vary a bit with the image on the screen because there is no voltage regulation, but I'll call that close enough. Okay, linearity. Alright, our image is currently a postage stamp. So let's try increasing the width. And then it gets jacked up and starts smearing over, and it's just a disaster. Okay, here's a trimmer cap. I have not touched it. I'm hoping it does something. I'm hoping it has a profound effect. So I'm using that same tool. Let's look at the screen while I adjust it. Oh, wow. Yeah, geez. That makes a colossal difference. Let's see, horizontal centering. Let's try going the other way. Let's see. I'm probably going to have to go back and forth with the width control and that linearity control. Now it shouldn't cover the entire screen because this set has a rectangular mask, so the right size is going to be somewhere around there. Okay, that's looking a lot better. I'll need to get a test pattern generator on there to really do it properly. And hey, wow, that's looking really good. Well, after a bit of tube swapping and replacing a few more out-of-spec resistors, things are looking better. I looked at the mask on the front of the cabinet and determined it's about 4 inches high and 5.5 inches wide. So I marked that out on the face using green Sharpie, which I can remove with alcohol easily. And I can just about fit this in. That's with the vertical height maxed out. And the width, I can make it wider. The width is not an issue, it's the height still that I just can't. If I increase the height anymore, it starts folding over. So it's about as good as it gets. The quick fix is to decrease the high voltage, which makes the deflection plates more sensitive because the electrons don't have as much energy, so they're easier to deflect. So if I have to, I'll do that. But there's something else that's been bugging me. The hum. The perpetual hum. So you can put the volume all the way down. It's pretty noticeable. And also notice there's some waviness to the image. There's slowly sine waves undulating through the image. So there's 60 hertz getting into the circuitry. And the reason why it slowly moves, some of you may know this, is that the vertical refresh frequency is no longer 30 hertz like it used to be. In other words, it used to be an exact multiple of the line frequency. But since they introduced color, it's actually 29.97 hertz, I believe now. Which means when you get some of the line frequency interfering with it, they're slightly different frequencies, so it slowly undulates. Alright, so where is it coming from, where is it going in, and what can we do about it? I don't know for sure, but one thing I can double check is the tubes. If there is any heater to cathode leakage, that could certainly cause this problem. Could also be a ripple in the power supply. That seems a little less likely to me since we have all fresh caps in there, and I'm pretty darn sure they're all wired in correctly. But that I can check pretty easily just by putting my digital multimeter in AC mode and checking the various B+ supply voltages. I don't know what an acceptable level of ripple is, but I would think if it's less than 1 volt ripple, that would be fine. Now something else. The horizontal oscillator and deflection circuitry is right here. The audio circuitry is right here. So not only do we have some interference in the horizontal deflection, we also have it in the sound. So maybe the two are related since the circuits are right near each other. So these two, well, the 12i7-7s, there's 4 of them right here. 2 vertical, 2 horizontal. Those have all been swapped out and moved around, so I doubt it's those. But maybe it's one of these, like maybe it's the 25L6 audio output tube. Those tubes, those beam power tubes tend to get driven pretty hard and they can develop grid leakage, which is another possibility. It could be grid leakage, it could be heater to cathode leakage. Heater to cathode is more likely because the heater is running on AC, so if any of the heater leaks into the cathode, you can feed 60 cycle hum into the whole set. Now there's something else. You may notice there's some foil here. Well, that is the coupling cap from the volume control to the grid of the audio preamp tube, I think it is. When we first started working on this set, the cap that was in there was bad and we had much louder hum, and replacing that improved it, but it didn't completely solve the problem. Oh, Sam's, why do you have to split the schematic right in the middle of the audio circuit? Let's try looking at a different version of the schematic, which is smaller, but it's still on one page. So we are here. So the volume control goes through this cap, and that is that cap that I have wrapped in foil right now. Goes to the grid of a 6AT6 and is a 10 meg resistor to ground. That is a super high impedance circuit. Now the signal going to the volume control is shielded. It is an early type of coax. It's up at the top right here. So they shielded the audio coming into the control, but then there's no shielding between the center tap wiper, I should say, going to the grid, and there's a 10 meg resistor. That is a crazy high impedance sensitive circuit. If I bring my hand near it, near that resistor, the hum increases. If I unground my shield, it gets louder. But now part of that is by me wrapping that cap in foil, the hum got louder. And if I attach anything to that foil, it gets louder still. Because I'm effectively like added an antenna to that circuit. If I ground it, it's better. It's not gone, but it's better. So yeah, even if it was the original paper cap and I took the outside foil and attached it to one side of the circuit, it still wouldn't solve the problem. Because both sides of that cap are kind of high impedance. I'm not saying it wouldn't help, but also even just these lengths of wire, just this resistor is sensitive. So I'm touching the body of the resistor now, or the wiper from the volume control. So in other words, this whole thing should be shielded, like maybe use a short length of coax. But let's check the tubes first. Let's check the 6AT6. The 10 meg resistor checks fine. And I could try replacing that too. What I could also do is I could put like this whole circuit in brass tubing. There were caps sold back in the day that had 3 leads. And there was a dedicated shield built into the cap that was meant to be grounded to help out with this. I'm also thinking, the speaker was relocated to the other side. Maybe that was to help with this issue, so I can certainly try swapping that to the other side. It does not have a field coil, so it's not radiating anything. It's just a permanent magnet. So I wouldn't think that just having the speaker present would cause hum. One thing I can also do is disconnect it entirely and put, say, a 4 ohm resistor to simulate a load. Get the speaker out of there entirely. Alright, so we have a few things to do. First up, let's check the tubes. Even if they check good, I'm going to swap them out anyway. 6AT6s and 25L6s are super common tubes. I've got some spares. All the tubes tested fine. So, went back to the drawing board. I did some research on some other models, used a similar chassis, and I went through the service info. I've also been posting on the Video Karma forum and have gotten some interesting suggestions. But let's start off with taking a look, not at the schematic, but at the physical layout of the circuit. Here's coax coming down from the detector. One side of the volume pot and the outer braid is grounded to the chassis. There's volume control. The other side of the pot is going to that tie point ground, and then the wiper comes off through this capacitor to the grid of a 6AT6 triode with a 10 meg resistor to ground. That's it. Really simple, right? It's also really high impedance and very susceptible to noise. It's just inherent in the design. No bypass caps. It's just whatever comes in is going to get amplified, and with really high impedance, so any noise is just going to get picked up. Also on this volume control is the power switch. This black wire snaking down here is one side of the AC line coming in. Other side of the switch is going right over to one side of that volume control into that same tie point. So it's not surprising that we're picking up hum. I mean, it would be surprising if it didn't pick up hum. Now, a few things. One, if we look at the SAMs for this, SAM's photo fax service info, that is. Here's our 6AT6 triode. They disconnect essentially the two internal diodes. They're not used in this circuit. 10 meg resistor to ground, a coupling cap or volume control. But notice there's something here. There's a dashed box around the volume control with a 5,000 picofarad cap going to ground. Also notice it's labeled as C53. Now that is significant for a couple reasons. One, if we go down to the parts locator diagram. Now, for better or for worse, the one thing I do like about SAMs is they do have photographs of the actual thing with designators, identifying the parts. Except that C53 is pointing to that, which is a 0.02 microfarad cap used on the opposite side of the chassis. And if we go down to the volume control, there's nothing. They made a mistake, sort of. I say sort of because if you look at the Teletone service info, which is a nearly identical design, here's C53 on that diagram, and that is a 5,000 picofarad cap going to the volume control. Which makes me wonder, were they reverse engineering both sets at the same time? That's what SAMs would do. They would buy a set. Instead of licensing the service info from the manufacturer, they would just buy something and reverse engineer it. So the Teletone version most definitely has that cap on the volume control. And here is the little snippet of the schematic from Teletone. I love the way they draw this. I'm being sarcastic. It's one of the most difficult to read schematics I've seen in a while. They did not put circles around the tubes. They just have the elements floating in midair, so to speak, with the pins labeled, but there's no circle around it. But anyways, here is the same volume control, and there is that 5,000 picofarad cap going to ground. Now also, in the service notes for this Teletone set, they talk about noise problems with the audio. It was a known issue back then. And they mention lead dress, and in particular they say don't do this. Don't connect the power and the volume control to the same tie point. So what I propose doing, two things. One, add that capacitor. Literally solder one leg of the cap to the body of this, and then I suppose I'll use that ground point. But also don't have this bare wire here. That is power for the set. One half of it, one side of the AC line. Let's cut that and instead route it over here maybe. There's a metal collar around this tube socket, so these lugs here, that is going to the chassis. Or potentially over here, this lug in the terminal strip, which is also going to the chassis. But not right here. And like so. I rerouted the other side of the power switch down to that tube socket. I did add a cap, but it does seem like this volume control metal body is already physically making contact with the chassis, so I don't know if that's going to do anything. Anyway, here we go. I'm back to using the PR57 Variac, so there is some background hum. We just have to ignore that. I'm also thinking I'm going to put the speaker back on the other side, if for no other reason than the mounting holes line up, and they don't on this side. Yeah, it's still got some buzz. Still has some buzz, I should say. But it's not terrible. It's less than it was earlier. I think both with swapping tubes around and changing the dress lead. So I was thinking if I really wanted to, I could, say, take a brass tube and put it over this capacitor and as much as the wire as I can, and then ground that. But when I turn the volume up, that's what I meant about having plenty of volume. So let's try that next suggestion of putting a cathode resistor in there, because the volume is booming as it is, so we can sacrifice some gain if it improves our noise situation. In a way, I'm glad this problem has occurred because it helps illustrate one of the points I've been trying to get across about the outer foil on the capacitor and whether or not it matters in the real world. Yes, there is a difference. Yes, you can detect the difference with some sensitive test equipment. In this case, we have a very high impedance amplifier. So yes, depending on which way I orient this capacitor, it's more inclined to pick up noise or hum. But guess what? So does the lead of the capacitor. So does the resistor. So does the pin on the socket. In other words, it's all high impedance. It's all picking up noise to some extent. If this really needed to work this way, it should be shielded in a metal box like this. Or it should be redesigned to be more immune to noise. Why did they design it this way? I think to save money, because it's a budget set. Here's the circuit again. Using a single resistor off the grid to ground is the cheapest, simplest possible way there is to bias a triode. So coupling cap, resistor to ground, a plate resistor, coupling cap to the next stage. That is the absolute simplest, cheapest possible way to make an amplifier. There are other ways that are an improvement. One of the problems with this is it's very sensitive to manufacturing variations. In other words, the transconductance of the tube. And it would be just the same issue with a transistor amplifier. Imagine it's an NPN resistor, which has its gain factor. And if you just grounded the emitter on that, you'd have the same issue where the gain is going to depend on the device. Swapping out the tube or the transistor can affect the gain, because not every tube is going to have exactly the same characteristics. So what is the better way to do it? Well, this, which is a more common design where you have a resistor in the cathode and a cathode bypass capacitor. That introduces negative feedback into the circuit. Yes, it reduces the gain, but it also fixes the gain so that it's far less less influenced by the component values. I got this circuit from RCA2 manual. Thank you for the suggestion on Video Karma. If you look in the back of an RCA2 manual, there is a section on resistor coupled amplifiers. And they give a few different types of circuits. Phase inverter, pentode configuration. Well, this is what we're going with. A triode with a resistance coupled amplifier. In other words, no coils or transformers coupling the stages. So this is what I want to add into the circuit, CK and RK. RP, the plate resistor, we've already got in the circuit, and we know what EBB, we know what our B plus voltage is essentially. That's 390K, that's about 120. Now if we look later on, they list different types of tubes and component values to use. So if we look through here, we find, hey, there's the 6AT6. This first column is plate voltage. They go 90, 180, 300. And we're closer to 90 than 180, so I kind of went with this. And our existing plate resistor, I assume these are in mega ohms. So what we are at 390K, so we're kind of right in between the 0.22 and the 0.47, so we're around about here. Well, I went through this and I figured cathode resistor, I went with an 8.2K, 10K would probably be alright too, and I chose a 1 microfarad cathode bypass capacitor. So that's what we're going to do. We're going to, I've already started working on it. I disconnected the cathode from ground, and we're going to put a resistor between the cathode and ground. I'm going to go with 8.2K, and we'll experiment with values. After a bit of tinkering, this is the final redesign I settled on. So what had been a 0.002 was increased to 0.01, the 10 meg was reduced to 470K, and a cathode resistor and bypass cap were added. A plate resistor stayed the same. And notice something? Set's powered on right now, and no noise. The only sound you might hear is the faint test tone coming through. So we still have plenty of gain, and it's far more immune to noise pickup. If I stick my hand in there, it'll still pick up some hum, but nowhere near as much as before, and I have not dressed these leads. These component leads should all be cut down. So why didn't they do something like this back in the day? Well, this does have a little bit less gain, and it uses more parts. This would have increased the cost a bit. So this was a budget-minded set. I guess they thought they'd get away with it, and it was hardly this alone. There are other lower-cost radios and TVs that used a similar design, just a single grid leak resistor for bias, and that's it. No just ground the cathode. Alright, so that obviously contrasts with the rest of the work I've been doing to keep everything all original. So what am I going to do? I could put it all back the way it was and accept that that's just a design limitation and live with it. Or, if I do leave all these parts in, I'm inclined to use all modern parts like I have here to make it really obvious to anybody that this was modified. And I could include a note, I could include the original cap and resistor. Actually, the resistor is still in there. I just simply put in a smaller value resistor in parallel with it. It's like art restorers do when they touch up a painting these days anyways. They use materials that are very easily reversible and that are very obvious to any expert that it's a touch-up, it's a modification. I'm going to think on it a little while longer, but for sure, if I leave this modification in, I'm just going to leave all the new parts naked and obvious that this has been added, this has been modified. Well, there's no point in me trying to cover this up. I screwed up. As I was going to put the speaker back where it was originally when I started the project, it slipped out of my hands just as I was about to put a mounting screw in and hit the floor and tore a piece out of the cone. Not the end of the world, it's a rather simple repair. It's just annoying because the cone was perfect when I started this project, and if I hadn't screwed around with trying to relocate it, it would probably still be intact, or if I had taken the precautions of covering it with, say, a piece of cardboard for, while I was working on the chassis, it would be fine. But at any rate, I've shown this before, but it's been a few years, I suppose. So what I did first was I took some Eileen's original tacky glue and diluted it like 2 parts water to 1 part glue, and went over the whole rest of the cone. The paper was super dry and brittle, that's why it broke so easily. By soaking the glue into it, it helps to strengthen it, barely adds any mass, doesn't really affect the characteristics. This is not a high fidelity speaker by any means to begin with. But what it means is this has less chance of tearing in the future. And it also, I used a little bit less diluted glue around the area where it was damaged. There was a split down here that's now been stitched back. So where it broke out, it just fragmented. I can't retrieve that piece and glue it back into place. I need to fill that void with something, and that something is going to be a coffee filter. Tea bags also work well. I tore a piece out near the outer perimeter, as it's a similar curvature to the speaker. I applied it from behind, it's not held in right now, it's just sort of floating there in position, and now I'm going to dilute some more glue, and I have a nice soft brush, and I'm going to start working it in from behind to secure it and fill in that void. When it's done, if I really care, I could put a little bit of water-based acrylic paint on there to blend in the color difference, but that's obviously not essential to its performance. That's a drag, it's my fault. You know, it's not the end of the world. Oh well. Here's a closer look at that reworked first audio stage. So we went from 10 meg to 0.47 meg for the grid leak resistor. Instead of grounding the cathode, we have a 4.7K resistor going to ground with a 4.7 microfarad cathode bypass cap, and the input cap was increased from 0.002 to 0.01. The set is on right now, and notice no hum being picked up before. If I got within a few inches of this, it was a loud hum. Now it's just gone. But it works just fine.
Mr. McGarrett, I swear to you, Byron had nothing to do with it. You better get a lawyer, Muella. Public defender's office won't cost you anything. Dano? I did my...
So no, it's not original, but it sounds so much better. I'm inclined to just leave it just as is. What also helped a lot was shortening up the leads and moving the capacitor body closer to the tube to keep this lead length short. I will keep the original cap that was there, and I want to leave these looking like this so it's obvious that this is not old work, that this is a new modern modification.